go. All right, ladies and gentlemen, so what we're going to do now, giving you some time to try these. If you messed up on these, you can't figure them out, that's okay. I'm here to save the day. Yes. Let you know, I'm definitely needing your safety contracts and things returned back to me. Some of you still have not signed up on Remind. It's ridiculous. You need to sign up on Remind. You're missing out on all the videos, like this lovely video that's going to upload later. So what we're going to do, I'm going to work through these. Where they are bigger problems, I am going to work through it with some speed. And then if we have questions along the way, stop me. If you got questions at the end, ask me. So I'm asking, determine the number of molecules in a 78.4 kilogram sample of nitrogen. So a lot of stuff going on here. First thing we need to do, you have to make a plan. Some of you can do this without the plan. Some of you need the plan. Plan helps. Where are we starting? Look at your number. I'll start you at 78.4 kilograms. What is kilograms a unit for?
Mass.
So we start at mass. And I'm wanting to go where? To molecules. But here's where the key comes in. Can you go straight from mass to molecules?
No.
Oh, we first have to go to mole. So starting off, we got a plan now, but take a look at something. I have 78.4 kilograms. Can I use that number?
You have to convert kilograms into grams.
You have to convert the kilograms into grams. If you do not convert into grams, you cannot solve this. Reason as to why, it's off the periodic table. The conversion factor comes in as grams per mole. We have to have them in the same units. So in that case, we set it up. So 78.4 times 10 to the third grams of nitrogen. I set it over 1. I did the conversion factor really fast. Now we're going to get from mass to moles. In order to do this, I need the periodic table. I set up my conversion factor. When I set up my conversion factor, I'm going to moles. Moles will go on the top, so 1 mole of nitrogen gas. In the denominator will go grams of N2. And the best part of it is, it's N2. Why N2 and not just N?
Because nitrogen is one of the 7 diatomics.
Nitrogen is one of the 7 diatomics. So that means it's bonded to itself. So we're not dealing with 1 mole of just nitrogen. We're dealing with 1 mole of nitrogen bonded to nitrogen. So it's not as simple as looking and saying off the periodic table that the average atomic mass of nitrogen is 14.01 grams per mole. Because you have a molecule. Nitrogen bonded to itself. I have 2 nitrogens times the 14.01 grams per mole off of the periodic table will give us 28.02 grams per mole. I take this number, it goes with the grams, so 28.02. Grams of nitrogen cancel. This was full of tricks. First trick, I start you not in grams. You have to catch that. Second one, I gave you a diatomic. You have to catch it. Mr. Hall told you. Mr. Hall will check you. Whenever you get the quiz from me, you should ask yourself one thing. Where's the trick? Now, next one. I'm at moles, I gotta get the molecules. I set up the conversion factor. I'm going to molecules, so molecules of N2 go on the top. Number that goes with molecules, the Avogadro's number, the 6.022 times 10 to the 23rd molecules. And over on the bottom, that's 1 mole of N2.
There needs to be an abbreviation for molecules.
So I'll divide by the 28.02, and then I'll multiply by the 6.022. When we do this, we get 1.6, a 0 times 10 to the 27th molecules of N2. Questions on this one? No questions?
Next one's hard.
The second one
Very hard.
is the hardest of the hard. It will slap you in the face and tell you, go home and cry to your mommy.
Is that the problem? Is that a problem or
When you look at it, determine the mass of a 72.5 cubic centimeter sample of hydrogen gas, atomic number 1, if the temperature is at 289.6 Kelvin and 1.8 atmospheres of pressure. Ladies and gentlemen,
Sample answer. I
I gave you a value for temperature
You can't do
and
it.
a value for pressure, which means
Can't do it.
That's why I didn't even start on it. I know you're just gonna do it.
can't solve not at STP. It's a good problem, yeah? I did this to you on purpose. I need you to realize a couple things. First off, when I give you a diatomic, you have to notice it. You have to double the average atomic mass. Second thing I have to get you to notice is if we're not at standard temperature and pressure, we cannot solve these. Now, what I want to do, Mr. Hall will give you 8 minutes. Because this is too big of a problem not to solve.
Well.
If at standard temperature and pressure. Hey, my man! Solve that baby now! Hey Siri, start timer for 7 minutes, 30 seconds.
minutes and 30 seconds, starting now.
Feel free to work together.
Because I'm not doing the test, yeah, term today. Oh, and 112 inside. It's supposed to be the last one.
All right. Here we go, man. I tell you what a problem. Hey, if you're not like knocking these out right now, and you're like tricking up, don't lose your confidence. I had tricks built in that. I have tricks built into this one. What this is now is meant for you to start seeing and catching tricks. I taught you how to do the mole conversions. Now I gotta get you taught to catch my tricks. So determine the mass of a 72.5 cubic centimeter sample of hydrogen gas at that standard temperature and pressure. First off, we're at standard temperature and pressure, so we can solve it. Second off, boom. First dead giveaway, there's a trick. Cubic centimeters. So where am I starting? Cubic centimeters is a unit of?
Milliliter.
It's a unit of?
Volume.
Volume. You're okay, you're ahead of me.
Got excited.
So where are we going from volume?
Mole,
To mole? Why we gotta go to mole?
you can't go from volume straight.
Thank you. You cannot go straight from volume straight to mass. You have to go to mole first, then we can go to mass. You're gonna like this. There's 3 tricks here. So the first one, Caden told you.
Oh,
Cubic centimeters.
Milliliters.
We have to make it into milliliters.
1 milliliter.
But then, you can't stop at milliliters. What's the conversion factor in?
Milliliters have to go to liters.
Has to be in liters. The conversion factor is in liters. Remember when we went through the mole map? I told you. This is one of Mr. Hall's favorite tricks. Mr. Hall always holds this in his back pocket.
J.C. Browning,
So be
Maggie Short,
prepared.
J.N. Atkins,
Okay?
Allison Plumley, Carson Painter,
There's 2. There's another one resting here. So let's set it up.
Logan Walsh, Shay Edmonds, David Toller, Hayden Godfrey, Hendrix Cook, Sarah Lilly, Paisley Shannon, Emily Miller.
-3.
Come to the office.
72.5 times 10 to the -3 liters. Set number 1. I'll go ahead and show it. So now we're going to move from here. We got to get to moles. So we're going to get to moles. We got to have a conversion factor. What goes on the top?
Moles.
1 mole.
Julia Jackson to the office.
H2. What goes on the bottom?
22.4.
Fancy number.
22.4 liters of H2.
E close to use.
So liters of H2 cancel. Now I'm at moles, right? So now we got to go to mass. So we got to set a conversion factor. What goes in the top?
Max.
So we got grams of H2.
Lit.
Here's the thing. Mole of H2 goes on the bottom. What number goes with the grams?
The atomic mass.
Something special
Double.
here though. This is a molecule,
Stupid.
not,
Stupid.
this is not just an element. Hydrogen is one of the 7 diatomics. So if it's a diatomic, it means it exists in nature bonded to itself. Since it's one of the 7 diatomics, you have to take the average atomic mass and what?
Double.
Double it. So we have hydrogen.
Stupid. Stupid.
There's 2 of them. Multiply it by the average atomic mass of 1.01 grams per mole. Which gives me 2.02 grams per mole.
Can we go talk about here, real quick? Please tell me the 725.5 was from when you converted the.
No,
It was up top and I just didn't see the point.
there's a decimal right there.
I did not see it. I still
Bruh.
can't see it now that I'm looking at it.
I saw mine completely wrong because of that too. I thought it was 725.
I'm sorry.
Your handwriting really sucks.
You want me to change it to 725? Did everybody else see the 725? Or did you see the decimal?
Yeah, I seen the decimal.
God bless.
I didn't see the decimal.
Get
This
sent
is
back in
favorite
class.
audio, just-
It's my handwriting. I apologize, everybody.
Oh God.
Listen, don't be getting sassy with me.
I mean, I still would have done it wrong because I didn't put enough paper that you got from the.
Yeah, his was like 65 anyways, so.
65.
Well, I didn't have in my paper anywhere that you got could convert to CM3. No, I just forgot to write it down.
Alright, divide by between 2.4. Multiply by the 2.02. Ladies and gentlemen,
Jesus.
Hey, you were still wrong though.
Interesting.
You're either right or wrong, it doesn't matter how.
0.0.
how wrong.
Yeah, I know.
0.065 grams of H2.
Are you sure? Yeah, I got that.
5 by 22.4. Yeah, I'm sure. What'd you get?
Oh, I put in wrong. I put 75.2.
Again, it doesn't.
You got me
matter.
all messed up.
It doesn't matter how wrong, it
Stupid
just
bastard.
matters that you're wrong, and that means we're both wrong. Even though I got 65.3.
Stupid dead.
So here's the thing. No, actually, like yours would be like worse. Like his, I could see on a quiz, and I would give him like
I mean, I was
a lot
right.
of partial credit because it literally
If there
was.
wasn't.
Partial
You
credit.
punched in something wrong with the calculator. Yours, I'd be like, oh man,
Mine wasn't even
I'm
that.
struggling.
I just messed it up because, you know, it looked like 725.
So 0.0065 grams of hydrogen. Do you have questions?
The next time, can you stick an hour and like an arrow out from the point?
Can you get Mary in here to code these with you just to write on the board for you?
Can you get Mr. Gibson?
All right.
We're going to something else.
So here's what we're
Is
gonna
it
do.
formula?
Okay. First off,
It definitely is.
take that. Math class is harder.
Hush.
Math class doesn't get.
Ain't nobody even said that. They was just lying to you.
So here's the thing. Okay, these are hard. So these are problems.
You don't have to do it.
You know the steps to do, but now what's happening is my tricks are catching you. Some of you are still lost in the steps, and that's fine, but this is where we're gonna have practice. Next week, we're gonna have some practice and work on some things too. I wanna encourage you on something though. Work together too. Don't be scared to work together. Some of you are doing it, you're doing it beautifully, and I see you literally helping each other out and you're getting it. So, keep working. You got this, I promise you, okay? All right. Now we're gonna do these. First thing we're gonna have, some of you guys are doing this, and I'm proud of you. Some of you are not doing it. Some of you don't need to do it, but others of you might need this. Make a plan. So, we're gonna make the plan. Where am I starting? To determine where you're gonna start at, what you need to first do is look at the unit that's with your number. So here's the number I give you, here's the unit. So that's micrograms, which is a unit of mass, so we're starting at mass. Now I'm going from mass and I want to go to molecules, but can I go straight to molecules? No, we have to go where first? There go moles. So this is like you want to go to Beckley. Well, you're going to Pineville or you're going to Bowl? You can't just go straight from mass to molecules. We got to go moles first. In here are embedded tricks. You have to catch them. Some of you are catching them, and some of you, my tricks are catching you. I openly do this in class for a reason, 2 reasons. Number one, come to your quiz, I'm absolutely going to put some tricks in there. Number 2, reason I do that in class and on the quiz. You're going to go to college and professors are going to want to trick you. I had a professor that he literally looked us straight in the face and he said, every question I give you, you should look and say, where's the trick? And he wasn't lying. So, trying to make sure it sticks. First problem we got, I'm in micrograms. If I'm going to deal with mass, what must I be in?
Grams.
You've got to be in grams.
Got
The reason for this is everything off the periodic table comes in grams per mole. So we have to get it to grams first. So we are looking at the difference here. I'm going to go ahead and change the number. So what I have is 36.5 times 10 to the something or another. So what I'm doing is I'm going from micrograms to grams. Grams are the same. Look at the difference in the exponents. The exponential value for micro, -6. I subtract the exponential value for the base unit is 0. -6 minus 0 is -6. But there's no exponent on the unit, so I don't multiply, but I still have to do step 5. I start you with an exponential value, so now you have to add that. So negative 6 plus 9 is 3. And my Dr. Silver come out, make my little thought bubble. So now I'm in grams, and here's the little foreshadow of the second tree. I'm going to go to moles. In order to get to moles, I need a conversion factor. Since I'm going to moles, 1 mole of Cl2 goes on the top. Grams of Cl2 goes on the bottom because that's where I'm leaving. But here's the thing. It's not as simple as grabbing a periodic table, looking and saying that your value is 35.45. Yeah, I remember that. We can go. Because it's not just one chlorine. Chlorine is a diatomic, which means it exists in nature bonded to itself. So what you have to do is you have to double the average atomic mass of it. So the average atomic mass of chlorine.
Just a reminder to the soccer team that there is no practice this evening, no soccer practice. At this time, our cross-country team is signed out. They are headed to a meet at Concord, and we wish them all the best of luck. Come down to the office and sign out, please.
So the average atomic mass of a single chlorine by itself is 35.45 grams per mole. But here's the thing. We have 2 of them, so you have to double that, which gives you 79 grams per mole. So now I got 70.9 grams of chlorine on the bottom. Grams of chlorine cancel out. That's all the tricks in this one. The next one, just set it up right. We're going to set it. I'm going to molecules of Cl2. Be over 1 mole Cl2, and the number that goes with molecules is Avogadro's number, 6.022 times 10 to the 23rd power. And then pop it in the calculator. One thing I'm seeing is some people are not sure when to do what with the numbers. So you'll always take your first number, type it in the calculator, then go here. This number is in the denominator, so I divide by it. This number is in the numerator, so I will multiply by this one. And we will get 3.1001 times 10 to the 26 molecules of Cl2. How you feeling with that? We're going to practice. Next week's practice. Okay? Here's the thing. If I tricked you here, that's okay, because I'm starting to add the tricks in now. Which brings me to problem 2.
What's a joke?
Determine the mass of a 96.8 cubic centimeter sample of bromine gas, atomic number 35. If the room is at a temperature of 301.3 Kelvin and 1.78 atmospheres. Here's the thing. I made a promise to you. If Mr. Ha ever gives you the values and the numbers for temperature and pressure, it's a dead giveaway. You are not at standard temperature and pressure. If you're not at standard temperature and pressure, can you solve a volume conversion? No. So here you go. Can't solve, not at STP. Easiest problem I ever give you, yes?
I did.
I'll tell you what though, this was such a nice problem, I think we should change it a little. How about if we did this? Let's get a little crazy, you know? Erase all this. Let's add something like, I don't know, you know, let's take that off before you ever Nazis get. Say at standard temperature and pressure. I'll give you a second in case you want to write this down in your notes below it. Because now what I've done is I've took the problem, I've put it at standard temperature and pressure, which means we can solve it now. You know, the math be mathing, the science be sciencing, it'll be a beautiful thing, yeah? We're gonna work through it together because it's 12:09 and I really don't have enough time to give you time to try it and me work through it and you have an understanding of what I did. Because the only way we could do that is if I did it in a minute, 30 seconds and you're just gonna write down what I did. You're not gonna comprehend everything. Oh, we're doing it. We're just doing it together.
Would Z M to the third just be one email or an email, right? One of that to be the.
Good catch. There's a trick. Look at you. You caught Mr. Haas
What you
trick.
yapping about, bro?
But that's okay, Riley. I have 3 tricks in this problem.
Oh, that's not so
I
good.
cannot take it.
Let's make a plan.
Let Mr. Hall take us all.
I don't hate y'all. I love y'all. I
Okay.
prepare you. You go to college, you laugh. You be like, this is the best you got. I survived Mr. Hall.
All right.
Where are we starting? Starting with volume.
Volume.
Cubic centimeters is volume. Where are we going?
Oh, somewhere. I don't know.
To mole.
And then to
Okay.
mass.
To moles, then to mass. Why do I have to go to moles?
You can't go straight from volume to mass.
So,
Shut up.
we gotta get there first. Here's the thing. Bravo, Riley. Riley caught a trick. We can't do that in cubic centimeters, right? What's the unit with the conversion number for volume at 22.4, what is that?
22.5, 12.4 liters.
Liters. Thank y'all. Okay. So we gotta get that into,
ML.
we gotta get an ml.
Oh.
So 96.8 milliliters of bromine. Okay. So now I'm good to solve the problem?
No.
Why?
Because you're difficult.
Oh, you see? Mr. Ha loved this chick for a reason. It's 2 for the price of 1. Mr. Ha, give it to you. Cubic centimeters is equal to a milliliter. What is the unit with the conversion factor for volume? It is liters. You cannot use milliliters. You have to use liters. So 96.8 times 10. Anybody got it?
26.8 times 10, -3.
What did you just say? That was gibberish.
He said -3. All it was is a metric conversion. We set it over 1. Hey, what unit goes here?
Nothing.
Nothing goes there. Still seeing some of you put a unit here. Nothing's going to go there with that 1. Now, you've got 2 tricks.
Wait, there's another.
BR2.
Oh, wait.
Let's do math.
There's another one, ain't there?
Yeah, there's 3 in this one.
Are you kidding me right now?
No, I'm serious.
I hate him.
All right, first thing we're going to moles. So what goes on the top?
One more.
So one more, VR2. Goes on the bottom,
22.4 liters.
22.4 liters. All right, so liters
What you make?
of VR2 canceled. Now, we set up, last conversion factor. We gotta get into the mass, yeah? How we gonna do it, man? You tell me, you give me the conversion factor.
Whatever grams over 1 mole.
Whatever grams.
The atomic, the mass of BR2.
Bromine.
Okay, so Riley says the mass of whatever BR is, so we,
Times
we,
2.
what? Why you times it by 2? I got on the periodic table with 79.90.
Are you kidding me?
I just realized that. There's up and down for that.
Riley, you're right. Why do we multiply by 2?
Oh,
Because
it's
it's one
a
of the-
diameter.
It's a diatomic. What is a diatomic?
It's the thing that's, they have two of each of the elements.
Elements in nature that are bonded to themselves. So you cannot just straight up do 79.90. That's for 1.
39.8.
Molecular mass for bromine, because it's bonded to itself, so it's a molecule, is 159.8. Look what happens. Moles of bromine cancel. Leaves me with mass. So let's
Wait.
toss it in. Should get 0.6906 grams of bromine. What are your questions?
That's a lot of work for a little number.
There's more. Hey, wait, what was the other trick?
Other trick was
He
the
rounded it
diatomic. Yeah, multiply by 2.
Oh,
Hey, how you guys feeling?
Mad about the first place.
Oh, I got your I got a whole practice sheet. I'm gonna print it
are you
already.
kidding me? You just did that, guys. Are you?
I already had it printed ready to go.
Are you serious?
Oh yeah, Miranda, she influenced me. I magically printed it and waited for a kid to ask. Yeah.
Hey, you know what today is?
Now you got like 4 minutes. I take a step. Just be safe.
What is today?
Do you know what today is? You don't know? You know? Hey, this clown don't know.
Although, you don't know what today is. Braxton, you don't know what today is. Fifth Friday.
That's pretty good.
That's a Walter told Miss Sanchez today in America we celebrate John Paul. She believed him.
That's so bad.
She said, oh, I'm so happy you celebrate John Paul.
What means fifth on Friday?
All right,
Freaky
look.
Fit
Here's the
Friday.
thing, okay? Come next week. I got a couple activities I got in mind for practice. Got a practice sheet for you.
That is not an activity.
We'll quiz on this next Friday. Okay?
Close your mouth.
Why am I saying that to you now? Because her heart just dropped and it's like 7 days. So, I mean, you know, a little less than 7 days. But you got time. Hey, if you have questions, come ask me.
27 negative E.
All right? Other thing is, if you do not have your safety contract from me yet, I need that. We will practice more, and I'm not baby-fighting it anymore, as you can tell. You guys are doing the hard stuff now. You remember the prop bob I did? This right here was two prop offs. You're doing this. I might be tricking you slightly, but before it's over with, you're gonna have it, man.
That's really great.